Ever wondered what happens inside a nuclear reactor? How can something so small as an atom release energy so vast that it powers entire cities? To unravel this mystery, we first need to understand the atom, the smallest unit of matter. Think of an atom as a tiny solar system, with a nucleus at the center, orbited by electrons. The nucleus is made up of protons and neutrons, and it's here where our nuclear story begins. In a nuclear reactor, the key player is uranium, a heavy metal with a nucleus so large that it's unstable. When a neutron hits the uranium nucleus, it splits or fissions, releasing a tremendous amount of energy. This is the heart of a nuclear reactor, a controlled chain reaction of uranium atoms splitting and releasing energy. But how is this chain reaction controlled? Enter control rods, the unsung heroes of the nuclear reactor. These rods, made from materials that absorb neutrons, are inserted or withdrawn from the reactor core to control the rate of the fission process. By absorbing neutrons, they prevent those neutrons from causing more uranium atoms to split. If the reaction gets too hot, more rods are inserted. If it's too slow, some are removed. It's a delicate balancing act, and it's what keeps a nuclear reactor from becoming a nuclear bomb. Let's take a closer look at how control rods work. They are inserted into the reactor core among the uranium fuel rods. When the control rods are lowered into the core, they absorb more neutrons, slowing down the reaction. Conversely, when they are raised, they absorb fewer neutrons, speeding up the reaction. So by simply moving these rods in and out, we can control the power of a nuclear reactor. Quite amazing, isn't it? Scene 5, from heat to electricity. The reactor's energy output is not merely unrefined, it manifests as heat. This warmth is utilized to induce steam from water, and the resulting steam propels turbines linked to generators, thus generating electricity. The system closely mirrors a conventional power plant, but as opposed to burning fossil fuels to produce heat, nuclear reactors unlock the energy ensnared within atoms. Scene 6, managing radioactive waste. Now you may be questioning the issue of waste. Indeed, nuclear fission generates radioactive waste, substances that stay radioactive for millennia. But fear not, these wastes are meticulously handled. Stored in dedicated containers, often far beneath the Earth's surface, they are kept from harming us or our environment. Scene 7. The summation. In a nutshell, a nuclear reactor moderates the fission of uranium atoms to unleash energy in the form of heat. This heat undergoes transformation to produce electricity. In order to manage the reaction rate and avoid a runaway chain reaction, control rods play a crucial part. The entire framework of nuclear energy is a fascinating interplay of physics, engineering, and meticulous control. It represents a remarkable application of how we have tamed the power of the atom to electrify our urban landscapes and fuel our world. The fact that we derive all this from an entity as petite as an atom is truly intriguing, wouldn't you agree?